Hello everyone, let's solve Leetcode problem number 49, group anagrams. So what does the problem says? It says given an array of strings, strs, group the anagrams together. You can return the answer in any order. So what is an anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So for example, EAT and TEA, so they consist of exactly the same characters, just arranged in a different way, right? So EAT, TEA, and ATE, so they are anagrams. So we put them together. Similarly, TAN, NAT, so they are just an arrangement of words. So we put them together in a list, and then the remaining one, BAT, we put that as a single list, and then we make a list of all of these lists and we return that. Okay, so how would we approach this problem? So one way that we can think about this can be that we try to find a common thing, right? So we try to find a thing that is common between all of these anagrams, right? So which is common between NAT, TAN, which is common between ATE, EAT, TEA, right? So we try to find a common thing that's common between the anagrams, and we can use that as a key, right? So whenever there is a new word and we want to check whether it belongs to this particular group or this particular group or this group, so we will compute that key for that particular word, and if that key matches with this group, then we will just add that into this list, right? So the high level picture or the bigger picture is that we want to have some sort of dictionary, right? So some sort of empty dictionary, let's say, and in that we want to have a unique key for every anagram, right? So this group of anagram will have its own key, right? We'll see in a moment what that key will be, right? So for this anagram, we'll have a particular key. And whenever we find a new word that also has the same key with this particular group of anagrams, then we just, whatever is the existing list here, we just append that word into this particular list, right? And then we can continue. So what can we use as the key, right? So that has to be something common between all of these three words. So let's see, we have these three different strings. So ATE, EAT, and TEA. And whenever we want to use something as a key in a dictionary, so it has to be an immutable object. So it can be an integer, it can be a float, it can be a string, it can be a tuple, right? But it can't be mutable objects. So the objects that can be changed, like a list or a dictionary. So the key can't be a dictionary or a list, but the values can be a list. So we try to find some key, some immutable object that is common to all of these three words, right? So that belong to the same anagram group. So one thing, so we will solve this problem in two different ways. So first, let's look at the first way. So what we could do is, if we think about sorting these characters, right? So there are three characters, ATE. So if we sort these characters, then what would we get? We would get AET, right? And again, if we have these three characters here, then if we again sort this, we will again get AET, right? And again, if we sort this one, we would again get AET. And again, let's say, for example, if there would be a new word, which would just be a rearrangement of these characters. So let's say I have a new word AET. So if I would also sort this, then I would itself just get AET. But I wanted to show a different example. So let's say we have something like ETA, right? So if this is our new word, then if we just sort this one, we would again get AET, right? So all the anagrams share this common feature, right? So for now, I'll just remove this particular thing. So this is our common feature, and we can use this sorted string as the key, right, as our key for this group of anagrams, right? So whenever we have a new word, we check if we sort that particular word. If we get this particular string, then in our dictionary we will have a list that consists of these 3 words. So we would just append that new word to this particular list, right? Similarly, let's say we have these two, NAT and TAN. So again, if we sort this one, what would we get? ANT, right? And also if we sort this one, we would again get ANT. So we can use this as a key, and the value will just be these dictionaries, right? So let's just go through this list and let's see what happens, right? So our strings, so let me remove all of these things, and let's just go through this example that we have here, right? So just a second. So we go through this strings, and let's say our dictionary or our final results is initialized as an empty dictionary. Okay, so first we go through eat. Okay, so first we go through this eat, we sort this. So after sorting this, what do we get? We get AET, right? We check if this key is in the dictionary or not. So if this key is not in the dictionary, then what do? We make this as our key, and as value we just add this particular word, right? So we are here right now, so we add EAT to this particular list, right? So this is our dictionary right now. Then we move on to our next word in the string. Then we see TEA, so we again sort this. If we sort this, then we again get AET, right? So now we check if in our dictionary AET is there. So if AET is already there, then what do? So whatever is its value, we just append it there, right? So EAT, so this will add TEA to it, right? Then we go to our next word, TAN. So if we sort TAN, then what do we get? We get ANT. So ANT is not there in our dictionary. So we make a new key, ANT, and to it we add this as a list, right? So TAN. Okay, then we move on to our next word, ATE. So if we sort this, then we get AET. We check if AET is there. So AET is already there. So in this list, we will also append ATE, right? So this will be our list here. And then we again go to NAT. So if we sort this one, then we'll get ANT. We will check if ANT is there. So ANT is there. Then to this list, we will append NAT, right? So this will be our new list. And then BAT, we'll again sort it, ABT. We'll check ABT, whether that is in our dictionary. So ABT is not there. So we will add that particular, right? And then ABT will have BAT, right? So this is our dictionary, and in the end we can just return all of these values as a list, right? So this is our first algorithm that we will implement. Okay, so what do we want to do? We want to have an empty dictionary first, so anagram. So this is what we will return, so the value of this particular dictionary. Now we want to go through every word, right? So every word in strs, so EATTA. So we want to go through all of this word. We want to first sort this particular word. So sorted word is equal to, let's say, sorted and word. But now keep in mind that if we use this sorted word, then it would return a list of characters, right? So if we do sorted EAT, then it would return a list of characters. So list of A and then E and then T. But we would want that as a string. So what we can do is we can join this particular list, because we can't use list as a key for a dictionary. So we would join that particular list. So we would get our sorted word. And now what we do is we will check if this sorted word, is present in our anagrams, right? So if this is already present as a key, then what do? We just append it, right, to our key. So anagrams and sorted word dot append, and to this we would just append the word. Okay. Whereas let's say if the sorted word is not present in our dictionary, then what would we do? We would create a new key here. So anagrams and then sorted word, and this will have a new list, and the member of this list will be the word, right? So this is what we want to do. And in the end, now what do we do? So this anagrams will have key. So key will be the sorted word, right? So for every set of anagrams, so we'll have a particular key, so the sorted word, and the value will be these lists. So we just want to return the values of this particular dictionary, right? So anagrams dot values. However, if we return this, so this will be a dictionary value. So we want to return that as a list. So we would return this as a list. So hopefully this code will run. Let's see. And yeah, this runs. Now if we submit it, then yes, it does quite well in terms of memory and also in terms of runtime. So now let's go back and just try to think of another way to solve this particular problem, right? So if we think about the runtime complexity of this particular algorithm, so what that is, so we are going through all these words once, right? So we have an outer for loop. So we are going through all of these at least once, right? So that will be n, right? So n is, let's say, the number of words in this list, strs. So that will be n. And whenever we go through one particular word, we sort it, right? So what is the time that takes to sort a string? So it would be, so if we are sorting in the best way, then it would be k log k, right? So where k is the length of this particular word, right? So our runtime complexity would be the number of words that are there, so n, and for every word we are using a time of k log k, where k is the length of that particular word, right? So in the worst case scenario, we just take the maximum, so whichever is the longest word here. So our runtime complexity in this case would be O of n multiplied by k multiplied by log of k, right? And k here is the length of the maximum word that we have. Okay, so let's just try to think in a different manner if we can solve this in a different way. So if we again have the same argument that we want to have a key that is unique to a group of anagrams, right? So other than sorted word that we have as common to all of these three words, what do we have in common? So let's say ATE. So if we think about the character count, so it has 1 A, right? It has 1 T, it has 1 E. Okay. Also for EAT, it has 1 E, it has 1 A, and it has 1 T. And also for TEA, it has 1 T, it has 1 E, and it has 1 A. So we could theoretically also use this as a key, right? But this is a dictionary that we are storing here, so we can't use a dictionary directly as a key. So we can have a tuple that we can use as a key, but in tuple the order matters, right? So we can't have like A1, T1, E1, so that would be different from E1, A1, T1. So the order in which we are putting this into the tuple would also matter. So what we could do is, we know that, so in the constraints here, it says that it consists of lowercase English letters, right? So what we could do is for key. So let's say we have a list of size 26. Okay, so list of size 26, and the first position here corresponds to how many character A do we have in that particular word. Okay, the second is, let's say, B. The third is for C. The fourth is for D, for E, and so on up to Z, right? So on up to Z. And in the beginning, we just initialize this list to 0. Now we can think that if we come across this particular word, ATE, so what do we do? So first we go through this character. So we see A, so we increment this to 1, right? And then for T, again, so wherever we find T, so we would increment that to 1, right? And then for E, we would increment that to 1. So for this particular word, so if we make this as a tuple, then we would get, so this would be 1, 0, 0, 0, 1, and then so on, and then again whatever is the position of T, we would again have a 1 there, and then rest would all just be zeros, right? So this would be a tuple that we would get for ATE. And now if you think about EAT, so if we again begin from zeros, then again we will get back the same tuple, right? Because we'll get E, and then we would increment E. We would get A, we would increment A, right? And then we would get T, and then we would increment T. So for this, and also for this, we would get the same tuple, right? And also now for NAT, what would happen is that we would begin with all zeros. Now for A, there will be an increment. For position N, there will be an increment. For position T, there will be an increment. So whatever tuple we get for this particular word, we will also get the same tuple for this particular word as well, right? So instead of using this sorted word as the key in the dictionary, we could use this particular tuple as the key, right? So this is just another way of solving the same problem. So let's go here and try to code this particular solution that I explained. So let me just change this solution 1. So this is solution. So whatever is the solution, Leetcode will be using that to analyze our submissions, right? So we would again start with the same thing. So Anagrams is an empty dictionary. And now what we want to do is we want to go through each word, right? So for word in strings. And now we want to start with an empty list, right? So empty list of size 26, and not an empty list, but a list with all zeros of size 26, right? Since there are 26 alphabets. And now what we want to do, so for a particular word, we want to go through every character. So for character in word, and in that position for character. So the first position of count, so the 0th position is for A, the first position is B, or the 1th, the position at index 1 is for B, then at C, then at D, E, and so on up to Z, right? So we want to get that index. Now, how would we get that particular index? So we have counts and we want to have that index. So what we do is that we take the ASCII value of this particular character, so odd char, so that will give you the ASCII value, and then we take it relative to A, right? So what happens is that if the character is A, then odd of A minus odd A, so that will be 0. If it's B, then odd B. So if all of them are lowercase, right? So if this is lowercase b, so A, odd A will have like 97, so odd B will be 98, so 98 minus 97 will be 1, so we'll be at index 1. If it's C, then this will turn out to be 2, so we'll be at index 2, and so on, right? So for every character, we would go to that particular index. And now what we do is that we just increment that by 1, right? So since we encountered a character at that position, right? So we just increment the value by 1. Okay, so we go through every character in that word, and then in the end, what will we have? So we'll have this list where only so wherever the characters are, so in that position we will get the number of occurrences of those characters in that particular word, right? So we can use this particular list, so we can convert that into a tuple, and now we can use that as a key, right? So what we'll do is that we will check, so if key is not in anagrams, right? So if whatever key that we got, so if that is not already there in our dictionary, then we would make that key, right? Anagrams key, and then the value there will be word, right? Whereas if the key is already present, then what we will do is that we will just append, right? So anagrams key dot append, and we will append the word, right? And now it again, so the difference between these two solutions is just that we are here the key was sorted word, whereas here the key is character counts, right? And then we are using that as a tuple here, and in the end then we want to just do what we did, so return list and anagrams dot values. Okay, so now this should also work. So solution, so Leetcode will take this as solution. So if we run this, then the test cases are passed, and now if we submit this, then yeah, it does decently okay, right? But our solution, the initial solution, was also very good. Okay, so if we just think about the runtime complexity of this particular algorithm that we use, so what we did, we went through every word, so that is n, right? And in order to create this count tuple, right? So create this count tuple, we went through every character in that particular word. So what will our runtime be? So our runtime will be, so we are doing n, right? So we are going through every word, and for each word we are going through every character, right? So n multiplied by k, so where k is the length of the maximum, so it's the maximum length of the word, right? So whichever is the maximum length word, so that will be k, and this will be big O of n multiplied by k. Okay, so these two are two different solutions, but overall the higher idea, if you look at it, is we are trying to find something unique, a key that is unique to this particular group of, to a particular group of anagrams, right? So in the first solution it was the sorted word, whereas in the second solution we did a character count and represented that as a tuple and used that as a key, right? So the overall idea is the same, just the execution is different in both of these solutions.